everyone, and welcome to our breakout session. I'm Michelle, an AWS Engagement Manager as part of Professional Services based in Melbourne. My role is to ensure that enterprise customers are able to innovate faster by working with Amazon, achieve great outcomes for their customers, and to enable them to think about the bigger picture outside of their particular project.
Hi, I'm Jess. I'm part of the High Performance Unit at Swimming Australia, and my role is Performance Solutions Manager. I have a background in sports science, biomechanics, and performance analysis. My job involves supporting athletes and coaches to find solutions for achieving performance outcomes. As the lead of performance support on the Australian swim team, I'm always finding ways to introduce innovation and improve the way we work in the team environment. Today, Michelle and I will be taking you through how AWS and Swimming Australia have partnered together to use data for a competitive advantage in the lead up to the Tokyo Olympics 2021 and beyond.
We wanted to see what AWS could do for swimming and what opportunities we could find to help swimming win on a global stage. In AWS, we have a mechanism which helps us to narrow our focus with a customer on what they want to work on. It's known as a working backwards workshop. At Amazon, everything we do works backwards from the customer. 95% of what we do is what customers tell us to do. Swimming Australia is no different. 2 years ago, AWS and Swimming Australia had an organisation-wide workshop which involved people from all facets: managers, coaches, swimmers, and data analysts. When we did this with swimming, a lot of their problems and opportunities were related to what constraints they have with access to their data. So we thought, what if we could unlock the value of data? What we discovered was that swimming had many systems that were collecting different types of data. Some systems capture local events and competition results, while the others captured training camps, physiology, and medical data. While these systems were built for a specific purpose and do a great job for that purpose, we wanted to be better. We need to be faster at getting our data and to turn around insights. Swimming had multiple resources spending time getting the data when they would be far better placed adding value via other means. The problem is that it takes so long to amalgamate all of these data sets. The sports and data scientists would struggle to put information together from these siloed systems, and they had no effective mechanism to gather international events and race data at scale. A common problem that we see across customers is that they want to realise the value from data. They only know what they know. Data is power, and especially in competitive sport. Take, for instance, the power of data analytics in the F1. F1 uses Amazon SageMaker to build machine learning models that help fans better understand the split-second decisions made by a driver or the pit crew that can dramatically affect the outcome. And take Bundesliga, the Professional Football Association of Germany. Using AWS, it's built its technology called Xgoals, which calculates the probability of a player scoring a goal when shooting from any position in the field. All of that is calculated in real time for every shot. This concept of unlocking the value of data is not new to AWS. We want customers to be able to retrieve and analyse data on their athletes and their competition to put them in the best place to win. Like many others, we suggested that Swimming Australia break these silos and put the data in one single unified data platform, which we call a data lake, Project Atlantis. Data lakes are modern data platforms that allow you to collect data from all your operations and sporting systems and put it into a single place where you can combine and integrate different data sets. In other words, collate all your data on one platform to enable faster queries. This is held on the Amazon service S3, which is actually AWS's first service ever launched. Swimming Australia is not a large enterprise. They do not have the luxury of having tens of IT staff to support their analytics workloads. So it was essential that we build them a solution that had very low or minimal operational management need. Over the years, AWS Professional Services has helped many AWS customers in building their data lake platforms. We have brought the learnings from these customer engagements into a single unified data lake offering called the Serverless Data Lake Framework, or SDLF. SDLF is an open source data lake framework and provided us the foundation we needed to build a complete serverless solution. In other words, we did not have any servers in the cloud or on-premise that needed supervision. The processing jobs would only spin up when the data was available to process and go away when it's finished, and the customer only paid for what they used. We scheduled jobs to connect to the source systems and pull the local events, races, and training data to the lake every single night. For systems that had no integrations, we simply allowed their sports scientists to export and upload the data to S3 in a safe location where we would pull data into the lake. We transformed this data from different source systems, which were in various formats, into a unified data format that can be queried efficiently from many services and interactive dashboards. We used AWS Lake Formation to catalogue all of the data. With Lake Formation, we centralised the security of the data lake in place. Our focus was to always keep in the front of our minds the ease of use for Swimming Australia post AWS leaving the engagement. We didn't want to build a solution that was too hard to use long term. AWS Lake Formation allows customers to manage and operate data lakes at scale and with ease. We needed to understand which opportunity would prove out the most amount of value to swimming's overall vision and what was possible within our time and resource availability. This process can go through several iterations to ensure that the highest impact opportunity is backed by data. I'll hand over to Jess now, who will talk a bit about the backgrounds of swimming's competitive nature and how we dived deep into the use cases. Over to you.
At Swimming Australia, we are the peak governing body for swimming, with nearly 1,000 clubs and 90,000 registered members nationally. Swimming is a unique sport as it's a life skill, a sport and a recreation. At Swimming Australia, our vision is to create a nation of swimmers admired by the world. We're striving towards this vision every day through aspiring Australians to be the best swimmer they can be. This is from grassroots through to elite level swimmers representing our country and themselves on the global stage. Each year, approximately 700 swimmers will qualify to compete at the national trials. The top 2 swimmers in each event, if they swim under the qualifying time, are selected onto the Australian team. This qualifying time is a top 8 in the world time. We have about 36 athletes on the national team, known as the Australian Dolphins. The Dolphins compete at the International Benchmark Meet each year with the rest of the world. This is either the World Championships, the Commonwealth Games, and every 4 years the Olympic Games, which is the pinnacle of world sport. Our goal at Swimming Australia is to be the top 2 nations in world swimming at the Olympics, and we always have the objective to win when it matters. Australia has a rich history of success at the Olympics. You'll all remember the most recent golden era, with Kieran Perkins going back to back, winning gold in consecutive Olympics in Barcelona and Atlanta in the 1500 metre freestyle, and then Grant Hackett taking over the mantle, winning the next 2 in Sydney and Athens. Or Susie O'Neill breaking a 20-year-old world record in the 200 metre butterfly that had been set by Mary T of the USA. And one of the most famous victories, the men's 4x100 metre freestyle at the Sydney Olympics, winning over Team USA, who had never been beaten in this event at the Olympics. This win was the start of a strong relay resurgence in Australia that reached new heights when the Australian swim team won a medal in all 6 relays at the Beijing Olympics, 2 gold, 1 silver and 3 bronze medals from the 6 relays. At every Olympics, on average, the Australian team wins 1/3 of Australia's total medal tally. And it's widely acknowledged that swimming is the premier Olympic sport in Australia. There is definitely a high level of pressure on the Australian swim team at the Olympics to perform and win medals. There's so much pressure on the athletes to perform to the best of their ability. Equally, the pressure on the coaches to have the athletes prepared and to make decisions in a challenging environment is huge. As a result, there is so much pressure on the support staff to provide fast and accurate data and information so the coaches and athletes are able to make these informed decisions. With the swimming being in the first week of the Olympics, it is often commented that the swim team sets the tone for the Australian Olympic team with the performance in the pool. If the swim team does well, the Australian Olympic team does well. The environment we're in, however, is changing, and it is getting more challenging to win on the world stage. It is evident by the fact that the average number of countries winning medals has increased. Since those heady days of the golden age, the data has exploded and Swimming Australia has had to keep pace. We have a number of new technologies for collecting data in the training pools, including such measures as heart rate, wearable technologies such as IMUs, which utilise gyroscopes, accelerometers and magnetometers, and instrumented starting blocks and walls to measure force production and velocities. And in the competition pool, we measure race metrics including stroke rates, splits, lap times, distance per stroke, velocities, skill times, starts, turns, and underwater kick count with custom race analysis software. We have the ability to analyse international race data from our competitors leading into and at the benchmark meets. This allows us to track current form of swimmers around the world, giving us greater understanding to the international trends in race performances. The internet and sharing of knowledge has also seen a shift in some training and testing methods. We are now starting to see the introduction of machine learning and AI in the swimming environment. What you often don't see is that behind every Olympic swimmer, there is now a team of people working with them every week. For this team to be most effective, there needs to be synergy. The coach leads this team of people and needs oversight in all aspects of the program. The philosophy of these teams is to be performance-driven, coach-led, athlete-focused, and expert-supported through an integrated team approach. The team monitors training and every aspect of the swimmer's performance and development through the training phases. To give you an example, the strength and conditioner needs to understand from the physios where the muscular functional weaknesses are in the athlete to be able to strengthen them to prevent injury, and what the focus is in the biomechanics to be able to physically prepare the athlete to be able to perform the specific movement patterns that are required. Or the biomechanist needs to provide the coach with feedback on the monitoring of the technique training sessions and understand the technical model the coach is working towards with the athlete. Our mission as a high-performance team is to enhance the capability of the coaches and swimmers striving for international success through a sustainable, aligned and driven high-performance system. The team of sports scientists and support staff all collect data to monitor and inform on the progress of the athlete. This is mostly done manually. To monitor the training session performances, we stand on the pool deck with the coach and record times and stroke rates as the coach is yelling them out to the athlete in the water between laps, whilst also recording heart rates and other metrics. We transfer this from our notebooks onto the whiteboard so the athlete and coach are able to see the full performance of the training session. There will be some immediate discussion at the completion of the training session with the coach, athlete and scientist on the initial thoughts of the training session performance. After the training session or testing session, the sports scientist will go back to the office and transfer this data into Excel spreadsheets or other analytical programs where all the historical data is stored and analysed. Or to analyse the international competition for upcoming international meets, we would have to spend hours and days scouring the internet for international results and then transfer them into Excel spreadsheets. As you can imagine, with all this handling of data manually, it is slow and can become siloed. The first use case we wanted to prove out was to test if we could bring two data sources together and what could happen. The best fit for this was the relay model. This previously lived on an Excel spreadsheet, which data was manually entered from web pages and results sheets. This process was very labour intensive and had potential challenges with reliability. The application that's been developed gathers historical race results and uses those results to enable us to explore scenarios around the order in which we might choose to swim our relay swimmers. When we're selecting the relay team swimmers from the Australian trials meet, we need to have a good understanding of what the current state of play is across the globe. We need to know the depth of our international competition. There's a rule in international swimming: if a swimmer is selected, they must swim in at least the heat of the relay at the Olympics. Essentially, you can't bench the swimmer if they're not swimming well when we get to the meet. For this reason, it is critical we select swimmers who are in good form and that their form is competitive with the rest of the world to qualify for the team in the heats for the finals. Once the team is selected, the next decision for the relay coach, when at the international competition, is who to swim in the heats, who to swim in the finals, and what order to swim the swimmers in. This is a strategic and tactical decision they need to make. With machine learning, the application makes suggestions on potential scenarios to swim the relay. The purpose of the application is to support coaches around this decision making in team selection and in tactical racing strategies. This saves the performance analyst a week in manual comparisons and having the ability to pull larger amounts of data instantly. It allows the analyst to get the information into the hands of the coaches sooner, allowing them more time to make an informed decision. At the Tokyo Olympics, the heats will be swum at night and the finals the following morning. The coach needs to make the decision of who and in what order to swim quickly to be able to tell the swimmers so they can begin to prepare physically and mentally that they will swim in the final. Time is of the essence in these pressure situations, so the more time you can afford the coaches to make informed decisions and the swimmer to prepare for peak performance is important. The second part to the analysis provides insight into the way the race could play out, to give swimmers and coaches awareness into the position they might be in when they are on the blocks, if they will be in the lead or behind at each changeover. This awareness will provide the athlete with the confidence to swim the optimal race plan that has been developed for that individual. And the third section of the analysis is a depth analysis or market share of an event. We have the flexibility to manipulate this graph by turning on and off different countries to interact with the data. This allows us at any point in the year to see the state of play. This shows us where our best 8 swimmers for the elected event rank and against another country's best 8. The next use case was automating our performance benchmarking. When you're aiming to be the best in the world, you have to understand what makes them the best in the world and how to do it. It was identified after the 2012 Olympics, Australian swimmers were falling behind in international skill performance levels. The first part to improving was to understand what the benchmarks were. We collect large amounts of competition race data at international competitions using our custom race analysis system, Sparta. We analyse our international competitors as well as the Australians at international swim meets. But we needed a better way to visualise this data and surface the world benchmarks for coaches. With this live report, coaches were able to see what the best in Australia are doing and compare to what the best in the world are doing. A coach will develop plans, 4-year plans based on the Olympic 4-year cycle, yearly plans to prepare for international benchmark meet of the year, monthly plans and weekly training plans. These plans are a critical part of a swimmer's development. They need to plan towards achieving and exceeding world benchmarks. This benchmarking historically has been done with Excel as shown on this slide. As seen here, this is just one page of 42 tabs of a worksheet. Again, taking an immense amount of time and labour to create these spreadsheets and to keep them current and up to date. A requirement of the development for coaches was to be able to self-service, which was critical. This allowed the data to be surfaced for coaches when and where they needed it. Previously, coaches had to wait weeks for manual processing and report generation. We started building the dashboards and gave the coaches access on their mobile devices. Reporting is now live and has interactive dashboards. The ability for coaches to view data on their iPads, on the side of a pool deck, in the middle of a training session, and not just on a desktop in an office, allows coaches to focus on coaching rather than data gathering. They can now use this data on the go in the field, and those mobile reports have solved a problem for them. With the new capabilities, we're able to build performance comparisons between local and international competitions and started comparing the world's best with the elite and developing athletes in Australia at the click of a button. This slide demonstrates an example of a race comparison report. This shows an athlete, coach, and performance support team how they compare at every stage of the race. Understanding the athlete's race development progression is crucial. We now have live reports and visuals to better understand the data. The comparison report is able to compare a personal best swim to the world's best in the same event. This is like a SWOT analysis for an athlete, looking at strengths, weaknesses, opportunities, and threats. It's also used as a critical analysis tool to know what areas need to be focused on for the next block or phase of training. Talent identification was a use case for our Pathways program. Athlete talent identification of the next generation of swimmers is extremely important to ensure a sustainable pathway and a sustainable podium performances. Our junior swimmers go through a series of standardised performance tests during training camps across the country twice a year. Coaches are now able to get instant analysis of rankings and testing results. With this data, we experimented bringing in artificial intelligence and machine learning models to help us identify the right upcoming talent. And we are making sure each athlete gets a fair ranking by correcting their age as a part of the algorithm. Our aim with this model was to provide a framework to assess performances of young athletes and identify their talent in a consistent manner and as early as possible. We asked experienced coaches to label performances of young athletes and gave this labelled data to Amazon SageMaker for a model to be trained on. It understood what the coaches look for in a good performance of a young athlete. The model gave us interesting insights into how each element of performance influences coaches' rankings or selection criteria. This will help fairly compare the data in young swimmers by the correction of age differences when comparing performances. We are now going to combine this data with the existing data that we have and industry-wide data to be able to identify patterns in upcoming young athletes in the pipeline. This experiment showed how we could utilise the capability of AI to rank our athletes, the way coaches rank and understand what makes a good performance. This was a proof of concept experiment to show what was possible with our data lake, Atlantis. There's 3 key points that we would like you to take away from this session today. The first is to innovate faster than the game. Training is the fundamental of any sport. Once you get to the elite competitive levels, you can't train harder, you need to train smarter, individualising training plans. We can now innovate faster because we have more information to turn into better information. The importance to connect and surface data sources to understand what the facts are and the information at our fingertips means greater insights into our athletes and what it takes to win.
Secondly, data is power. We want to unlock the potential for the future and stay ahead of the competition. We have only scratched the surface and analysed what we know. But what about what we don't know? Imagine the possibilities as we start to unlock more insights that disrupt the competition.
And the third is the art of the possible. If this is what has been achieved in 12 months with data in one place, imagine the next Olympic preparations for Paris 2024, Los Angeles 2028, and who knows, maybe even Brisbane in 2032 can be. We can compare to F1, which is heavily data-driven, and they have leading-edge insights. We will look to revolutionise the sport of swimming and competitive landscape with AI and ML to gain insights. with Amazon and cloud technologies making innovating easier and faster. Being innovative leads to better speed, better ideas, better human interactions, and better performance. With the preparations for the Tokyo Olympics in full swing, and our coaches are now able to access data when and where they need it, even if that's on the side of a pool deck midway through a training session. This enables them to make informed decisions, set high standards and world-class benchmarks for our athletes. The goal has always been with AWS and Project Atlantis to have an impact on the pool deck and improve the way coaches interact with data, providing them the opportunity to make informed decisions and grow their knowledge and insights into swimming performance. When it comes time to select the team to go to compete in Tokyo at the Australian Trials in June, we will be able to again make more informed decisions, in particular around our relay teams. Thanks for joining us today. Over to Michelle for some more details on AWS.
You join the AWS Summit to learn, and you can keep the learning going after the summit with resources from AWS training and certification. We offer over 65 courses, many available free and on demand, as well as virtual instructor-led training. AWS experts will help you and your team learn to apply machine learning to your business, unlocking new insights and value. When you're ready, prepare for the AWS Certified Machine Learning Specialty Exam, which validates your skills and provides an industry-recognised credential. For more information, visit aws.training/machine learning, and be sure to check out our AWS Ramp-Up Guide to learn more. Thanks for watching. If you enjoyed this session, please complete the session survey. Your feedback would be very much appreciated.